size 1124, 111, 212, and the mean is 17.3, 17.5, 18.4, and the standard deviation 3.7, 4.0, 4.2. Oh, that was the other part that made finding an article hard. They don't always include the standard deviation, so. If you find another article with one-way ANOVA that includes all of this information, I'd like to see. I'd like to see one just because, I don't know, maybe this is of interest to our class. But it's all they said was people start smoking at different ages. That was essentially the conclusion. They said, well, and you know, different groups, maybe they start smoking at different ages. So maybe we can do something about that, but.
Why is the sample size so different?
Because they had a lot easier time finding.
But doesn't that hurt the statistics? Doesn't that hurt the result?
No, it's all taken care of when we do our degrees of freedom and stuff like that. So.
Those are probably representative of the actual.
Yeah. Yeah, I don't know where they took their samples, but maybe they were taking samples in what might look like this. I don't know. Okay, some place that probably had the details. Okay. You can read the article in detail if you want, but okay. So anyway. Let's see, let's create our ANOVA table, okay? So we have source, and we can call this between groups, within group, variation. Alright, so we have degrees of freedom. And then we have sum of squares, and then we have mean squares. Okay, so degrees of freedom is easy enough. We just take number of groups minus 1, so we have 2 degrees of freedom there. Within is total number of people that we have is 1447. Okay, and then the grand mean. I guess we could calculate it ourselves, but if we just take the reports number at their word, they said their grand mean was 17.5. Okay. So this would be 1447 minus 3. 1444, and I have total degrees of freedom 1446. Okay. Well, I guess I'll leave it to you to find the sum of squares and mean squares. So I'll put I'll slide this up and I'll put the correct formulas for those things. this what we got? I don't know. Are you guys getting the same? More or less? Okay. And then mean squares, we would then divide this by 2. What do I get? 108.34. And over here I would get, what would we get? What's that? 14.44. And so my F ratio would be 108.34 divided by 14.44. And what does that equal to? 7.5. Okay. Good. So we can go to our F table, and we would use numerator degrees of freedom 2, and denominator degrees of freedom, I don't know.
Infinity?
Yeah, something between 140 and infinity. Okay? And if you look at that, our F ratio of 7.5 does seem to be quite close to, you know, fits within, right in that range of around 0.001. Okay? So in the table, with numerator degrees of freedom equal to 2 and denominator degrees of freedom, if we look at 140 and infinity, when we look at the relevant values, we have 7.26, 6.91, and 9.84 and 9.21. And this corresponds to 0.001, and that's 0.0001. Okay, and so 7.5 does indeed fit within this column. Okay, somewhere around here, and it does seem, in terms of, is it closer to this number or that number? It does seem to be closer to this value. And plus ours wouldn't be exact because we didn't have the exact mean. We just took 17.5 as a good enough number for the mean. And so, you know, I would say, yeah, our F ratio, our own calculations seem to indicate that the p-value is around 0.001, maybe a little less. Okay. All right. Why don't we take a little break, and then so I'll say a few more things about ANOVA and stuff after the break. But we'll take a break. I'll say a few more things about ANOVA, and then we'll